On page 184, we have some nonlinear systems. So if you look at the first problem, we have the graph of a line, and this is a y squared equals x plus 3. So an x squared graph is a vertical parabola. A y squared graph is a horizontal parabola that opens to the right. So it's not a function because it doesn't pass the vertical line test. But if you look at the graph of a right opening parabola and a line, it still might have two intersections. It could have one and it could have none. We don't know until we start solving it. Now, whenever you're dealing with nonlinear systems, the best option is elimination. However, elimination doesn't always work. If the variables line up in such a way, or you can rearrange them in such a way that you can eliminate one of the variables, it usually makes things easier. Okay? But in this case, we really can't. So we're going to use substitution. I guess we could. Well, okay, let's go ahead and try it. So I'm going to subtract the x over. So minus x. I'm going to rewrite. So y equals negative x plus 6. So yeah, you can use elimination on this. What is y squared plus y? No. What's y squared plus y? Y squared plus y. So on the left side, we get y squared plus y. On the right side, the x's are going to cancel, and I get equals 9. Well, this is a y squared equation, so I need to set it equal to 0. So I need to move that right side over to the left. So I'm going to subtract 9. And I get y squared plus y minus 9 equals 0. Well, what I'm really looking for is, where does that sideways parabola touch the y-axis? So we're just going to try to factor it and pretend that it's an x squared equation. So we're going to find the roots. Are there factors of negative 9 that add to be 1? Well, we have 1 and 9, or 3 and 3. Do either of those work? No. So guess what? We got to use the quadratic formula. So the quadratic formula, negative b, so negative 1 plus or minus the square root of 1 squared is 1, minus 4 times 1 times negative 9 is plus 36 over 2 times a, which is 2. And that's not really going to simplify much. Negative 1 plus or minus the square root of 37 over 2. So those are the y values. They're not nice numbers, which we're just going to have to deal with. How do I find the x values? Plug it back in. So if I look at these equations right here, so I want x equals y plus 6, or 6 plus, minus y. So I need to stick this terrible answer in for y, which is not as hard as you might think. So 6 minus negative 1 plus or minus the square root of 37 over 2. Well, how do I add 6? How do I take 6 and subtract a fraction from it? I make 6 a fraction. What fraction do I need to turn it into? 12 over 2. So this becomes 12 over 2. And then it's easy. We have 12 minus negative 1. What is that? 13 plus or minus the square root of 37 over 2. Those are my x values. Now the nice thing is that's as hard as it gets. Okay, most of the other ones are a lot easier than that. Okay. So number 2, can I use elimination? No. Is there any way to take an x squared and subtract an x from it and get a 0? No, there's no way. So I'm going to turn the bottom equation into y equals x plus 1. Everybody get that? Okay. So I'm going to take x plus 1 and substitute it in for y. X squared plus x plus 1 squared equals 41. All right? X squared plus, how do you square a binomial? You have to distribute it out. So what I don't want you to write is x squared plus 1 squared. That's not right. So it's x plus 1 times x plus 1, which is x squared plus x plus 1, so plus 2x plus 1. What about this 41? I need to subtract it to the other side. So minus 41 equals 0. Anybody confused up to that point? No? Okay. So 2x squared plus 2x minus 40 equals 0. We good? Can I make this any easier? Divide by 2. So x squared plus x minus 20 equals 0. Now hopefully it factors. If it doesn't factor, we have to use a quadratic formula or complete the square. Are there factors of negative 20 that add to be 1? 4, negative 4 and 5. X minus 4 and x plus 5. So my x values are 4 and negative 5. To find my y values, I'm going to plug them in here. Because it's x plus 1 equals y. So 4 plus 1 is 5. So the first point is x equals 4, y equals 5. For the second point, negative 5 plus 1 is negative 4. And those are my two intersection points. Okay. Let's look at number 6. Now, some kids in my last class said, hey, if I square root the top, it equals the bottom. What do you think? Why not? Well, if I square root this and square root this, what's the square root of 4x squared? 2x. Well, I have a 2x. What's the square root of 9y squared? 3y. I have a 3. What's the square root of 36? 6. So why doesn't it work? Here's the reason. If I did 4 plus 9 and square rooted that, is that the same as 2 plus 3? Right, you do the inside first and you get 13. Is the square root of 13 equal to 5? Not even close. Square root of 13 is 3.7. Okay. The reason is, in order to square root a binomial, it's got to be a perfect square like this. Right? And if I distribute this out, I get x squared plus 4x plus 4. And then I could square root that, and I would get x plus 2. So it's really complicated to do it that way. So you can never square root a binomial or a trinomial. If there are two terms, even if both terms are perfect squares, it doesn't work. Which is what you guys already knew. If I had x squared minus 9 and I square rooted that, is that x minus 3? No, x squared minus 9 factors into x minus 3 and x plus 3. So don't get stuck in that trap. That's not actually possible. Okay, so what do we do instead? Can we use elimination? Can I multiply the bottom by something so that an x cancels or a y cancels? But then I have an x squared and a y, or a y squared and a y, so the y's won't cancel. If I squared the bottom, I would get 3y plus 2x times 3y plus 2x, which is 9y squared plus 12xy plus 4x squared. Well, that's nice, except now I've created an xy term, so that's not going to work. So, yes? If I multiplied the bottom by 2x, I would create an xy term, and then I wouldn't get rid of them all. So there's no way to use elimination on this one. You have to use substitution. The trouble is, substitution is a little bit painful. So it doesn't matter whether you do x or y. So I'm going to subtract 2x, and I'm going to divide by 3. So y equals 2 minus 2 over 3x. And that's what I plug in for y. So in the top equation, 4x squared plus 9 times, what is the square of this? Well, so I'm going to plug in 2 minus 2/3 x, and I'm going to square it. So 2 minus 2 over 3x, and I'm going to square it. Well, I need to distribute. So 2 minus 2 over 3x times 2 minus 2 over 3x. 2 times 2 is 4. That's the first one. And what's 2 times negative 2/3 x? You don't flip it. You just do 2 times 2 and 1 times 3. So minus 4 over 3x, and the next one is also minus 4 over 3x. And what's that? 4 over 9x squared. So plus 4 over 9x squared. Okay? So 4 minus 8 over 3x plus 4 over 9x squared. And what do I do to this? Times it by 9, which is nice because the fractions are going to go away. So I have a 4x squared plus, and I'm going to do 9 times this one, which is 4x squared plus, what is 9 times negative 8 over 3? So 9 times 8, 72 divided by 3, is it 24? So minus 24x plus 9 times 4 is 36. So 8x squared minus 24x plus 36. Oh, how nice. Can I make it at least a little bit easier? Divide by 8. No. 36 is not divisible by 8. 4. So 4x squared minus 6x plus 9. So now, oh, 2x, thank you. That's even better. So 2x squared minus 6x plus 9. Well, we could try to factor it, or we could use the quadratic formula. Yes. Oh, did I leave something out? Oh, you're right. So this equals 36. Oh, man, that makes it so much easier. Sorry. So, glad somebody's paying attention. So I have 8x squared minus 24x plus 36 equals that original 36. If I subtract 36, thank you, that saved us a lot of work. So I have 8x squared minus 24x equals 0. How do I solve that? I can plot an 8. I can actually just divide by 8. And I get x squared minus 3x equals 0. Now what do I do? Well, I can't factor this like a regular quadratic because it doesn't have a constant. You could put in the quadratic formula, but that's way more work than you need to do. Do these have any common terms? X. So I pull out an x, what's left? X minus 3 equals 0. Well, what is the root for that one? 3. What's the root for this one? 0. So we set this equal to 0, and it's just 0. We set this one equal to 0, and it's 3. So my x values are 0 and 3. Now what? Plug them back in. So I have this equation y equals 2 minus 2 over 3x. If I plug a 0 in there, what do I get? Ignore the squared. The squared's not there. Y equals 2, so 0 comma 2. If I plug a 3 in there, what is 2/3 times 3? 6 over 3, which is 2, and 2 minus 2, so y equals 0. All right? Is your head exploding? Okay, you have 25 minutes to work on this assignment. It's due tomorrow. Good luck.